Today on Convergent's Corner, we're going to look at infinite geometric series. Now, an infinite geometric series has an infinite number of terms. What we've been looking at up to this point is a series that has 4 terms or 5 terms or 20 terms, and we've been able to add them together. This time, we're looking at an infinite number of terms. Now, a convergent series is a series that has a sum because its sum converges to a specific value, and we'll look at examples. A divergent series, on the other hand, does not have a sum. So let's look at some examples here, okay? When we have a convergent series, we have the sum approaches a finite value because the R value, right, the common ratio is less than 1. So what happens is the numbers are going to get smaller. And as they get smaller, as you add them, it's not going to get much of a difference, right? As we go, it's smaller, smaller, smaller pieces. As opposed to divergent series, we cannot find a sum because these values are going to be getting larger, right? So what happens is, as they go on to infinity, these values are going to get bigger and bigger and bigger, so we can't possibly put an estimate on the sum. All right, so let's look at the sum formula. Okay, so we have sum. We've dealt with this before. A sub 1 is our first value. R is our common ratio. Now, again, anything that is greater than or equal to 1, the ratio, the series has no sum. If we look back, again, our convergent series, the R value is less than 1, and divergent R is greater than or equal to 1. All right, so at this point, let's look at number 1. Now, it's hard to tell whether our fractions are getting bigger or smaller, right? Because those numbers are not so easy to identify. So again, like we've done in the past, to find the R, I'm going to work backwards. R is equal to, and I'll take 6 over 15 and divide it by 2/3, and I end up getting 3 over 5. That's R. So because the absolute value of 3 over 5 is less than 1, this means that the sum exists. So we can actually find a sum. So now we're going to go up and we're going to use our sum formula. So our sum is equal to our A sub 1 is 2/3. And then 1 minus our ratio is 3 over 5. Now, if you put that in your calculator, we're going to get approximately 1.7. So even though those numbers go on and on and on, they're getting so small, we're really never getting bigger. We're never even getting to 2, okay, as an approximation. Now, just to kind of show you why that works, if I take the values, the first 3 values given above, and I were to add those together, I would get 1.3, right, which is not really that far away from 1.7. If I add one more number in that series, and I have 2/3 plus 6 over 15 plus 18 over 75, and I multiply that by 3 over 5, I get 18 over 125. And again, that's approximately 1.45. So even as I add just one more value, I only went from 1.3 to 1.45. So I really did not move a lot. So again, as those values get smaller and smaller, I'm going to approach 1.7, and I'm not going to get too much higher than that. All right, let's take a look at number 2. Now, again, trying to figure out what the ratio is, I take 20 divided by 16, and I get 1.25. Now, that absolute value of 1.25 is greater than or equal to 1, so no sum exists. So as you think of this, as the numbers start getting bigger and bigger, they're going to keep getting higher to infinite. So it's going to be difficult to put an exact value on a sum because the numbers are going to be so big, which is why we say that no sum exists. All right, so now let's take a look at the infinite series in sigma notation. We've done that in the past now. Now this means infinity, right? We're going to start at 1. Our k value is going to be 1. Remember this 4/5, that's our ratio, that's our common ratio. So let's find our first term, a sub 1 is equal to 18. Now again, I'm substituting into this expression, times 4 over 5. My k value is 1 because of what we start with there, 1 minus 1. So I have a sub 1 is equal to 18. Now 4 to the 5th, this ends up being 4 to the 5th raised to the 0 power, right? Anything raised to the 0 power is 1. So my a sub 1 has a value of 18. Okay, now I can use my sum formula. So I have 18 on the top, 1 minus, now again, my ratio is 4/5. So with this, my sum has a value of 90. Thanks so much for stopping by today. You have a great day.